All right, so we're going to deal with real world-ish examples. Here we have a ride. The swing arms of the ride at the right are 84 feet long, and the height of the axes from which the arms swing is 97 feet. What is the total height of the ride at the peak of the arc? Now, you might think, wait a second, if the arm is 84 feet and the place from which it swings is 97 feet, wouldn't I just add 97 plus 84? The problem with that is that the ride doesn't go all the way around. It's not a Ferris wheel, it's a swing. Now, if you've ever swung before, you don't go all the way around. You only go to up to a certain place and then you swing down to the other side. So in the picture, it's showing the maximum height that it's going and the angle from which it initiates from. So we can see that this is going to be a negative 200-degree angle here. Now there is a couple things that we need to do to figure this out. First of all, we know the hypotenuse of the triangle. You might say, whoa, where's this triangle that you speak of? The triangle is right over here. There is one side, there is one other leg, and here is the hypotenuse. We have a triangle. Now, if we need to figure out y, we need to use some type of trig function to do so. Now, this is going to be our angle of the triangle that we're going to be working with. We don't know that angle, but we do. How do we know that angle? Well, we know that 200 degrees is going that way, so if we just subtract 180 from it, we would find our reference angle. So that little section right there is just going to be 200 minus 180, which is going to equal 20 degrees. Now that is pretty cool, but this does go back a few lessons. We know a couple things about this. We are trying to find the opposite side. We know that this is going to be the opposite side because I can draw an arrow going across my triangle to point at the y. So we're trying to find the opposite side and we're using the hypotenuse to do it. So what deals with opposite and hypotenuse? SOHCAHTOA can help us out here. SOHCAHTOA, let's see, what deals with opposite and hypotenuse? It looks like sine deals with opposite and hypotenuse. So we're going to use this. We know that sine of theta is going to equal opposite over the hypotenuse. So sine of our angle, which is 20 degrees, is going to equal the opposite, which is y, and over the hypotenuse, which is 84. Now we just solve this out for y. I can see right off the bat that all we have to do is multiply both sides by 84, and we should be able to just solve this out. Y is going to equal whatever 84 times sine of 20 degrees equal. That is something we can just use Desmos for. So as you can see, we have 84 times sine of 20, and we get this interesting decimal value here. But we have to ask ourselves, is our calculator in degrees? We're using degrees in here, so our calculator has to be used in degrees. Now this is a mistake that a lot of people, even the best of us, make. So make sure you always ask yourselves, wait, is my calculator in degrees? Well, let's hit this settings button on Desmos, and down here it was in radians. So we have to change that to degrees. Once we do, we can see that it changes our answer completely. 28.729. So let's write that out, 28.729 on our answer. 28.73, let's say, instead of saying 29. Now this is not the end of our answer because we know, looking at the picture, we have found what our y is. But that is not what the question asks. It's asking how tall is the ride at the apex of this swing. So we know that the regular height is going to be 97 feet. So when we add on that 28.73, what do we get? So we're just going to add these two values together, plus 97, and we get 125.73 feet tall. Now give this guided practice a shot. It's actually the exact same word problem, except you're replacing some of the values with it. So you could even look at the picture, but just replace the values that you see there, and you should be able to find out the answer to this. Good job on pausing the video and giving this a shot. So, what did you get? Well, let's see what we get together. Now, the first thing I'm going to do is use the picture that we used before. The only difference is that we're going to replace some of these values. Let's see what we have to replace. A similar ride that is smaller has swing arms that are 72 feet long. So instead of saying 84 feet, we're going to say 72 feet. What else changes here? The height of the axis from which the arm swings is 88 feet. So instead of saying 97 feet, we're going to say 88 feet. The angle of rotation that the standard position is negative 195 degrees. So instead of negative 200 degrees, we're going to say negative 195 degrees. Now we're going to do the same thing, is that we're going to draw our little triangle here and realize that we're finding the exact same side of the exact same triangle, only with different measurements. Now, first thing that we want to do is we want to figure out what is our reference angle. Now, I did a little shortcut in the previous example, and I didn't really follow the rules that I set out in the video that we made. And if that makes you uncomfortable, just find the reference angle however is best suited towards you. However, we can find this reference angle by taking 195 and subtracting 180 degrees from it, which will give us 15 degrees. So we need to find out what our side is using our 15 degrees. Now again, from the last video, you would already know which trig function that we're using to find this, but to reiterate, we are trying to find my opposite side using our hypotenuse. So what uses opposite and hypotenuse? That's going to be sine, and we can get that from our SOHCAHTOA. So we know that sine of theta is going to equal opposite over hypotenuse. So filling in what we can, sine of 15 degrees is going to equal the opposite side, which is y, over our hypotenuse, which is 72. And we get to solve this in the exact same way that we did before. We're just going to multiply both sides by 72 degrees and then type that into Desmos to figure out what is our 72 times sine of 15 degrees, because that will give us our y. So as you can see here, 72 times sine of 15 is going to be 18.63. Now, if we remember from our last problem, we're already in degree mode. However, we could be extra special, sir, by clicking on the settings and looking. But we can be extra special, sure, by clicking on the settings and finding that we are in fact in degree mode. So let's go back and use 18.63, and we know that y is going to equal 18.63. Now that is not the end of our question. We know that because we have just found the part of our triangle that will give us the extra bit of height over the regular size of this ride. We know that the regular size of this ride is 88 feet tall, so all we will have to do is take 18.63 and add 88 feet to this. That is going to equal 106.63. Good job.